graph using a T-chart, the basics. So I want you to recall a couple of things. The best way to graph a line in slope-intercept form is to use the slope and the y-intercept. There is no better way, okay? I don't understand why books and teachers ask you to do other things, but until I get a good reason, I'm never going to say that and do it, so I haven't got a good reason yet. You always start with a point on the graph, so start with the y-intercept, which will either be up for positive b or down for negative b, and once you have this point plotted, apply your slope from that point and rise over run, okay? Recall, the best way to graph a line in general or standard form is to use the x-intercept and the y-intercept, okay? No better way. There's no need to change that and solve for y and all this other stuff, okay? I know you're asked to do that and software packages will. Every software package I've ever used does that. I still don't have a good reason why that's useful. Why not be efficient and do it the best way that it is given to you? Sometimes, however, you have a line that is not in one of the given forms, okay, above, meaning it's not standard form or general form or slope-intercept form. While there are multiple ways to attack such a situation, this video will focus on using a T-chart to graph. And quite frankly, a T-chart is something that will always work. You could always do a T-chart if you wanted to, okay? So while you only need 2 points to graph a line, if you notice the methods when we're given like a y-intercept and then apply the slope to get another point and then graph it, or the two intercepts, x and y-intercepts, and then graph it, okay? And sometimes the x-intercept is the y-intercept, which is the origin. You only get 1 point. You got to find another point. And a T-chart helps you with that because you're plugging in a value and getting another value out, all right? So, but we typically find 3 points when we use a T-chart, and that's just to make sure we check. So if we get a point here and a point here, we have a line, but what if our third point's over here? We messed up somewhere, right? We need to find another point here so we have a line, right? So that's why you find a third point, just to make sure you didn't make a careless mistake as you were plugging it in or whatnot and simplifying it. So here, let's quickly talk about why it's called a T-chart. Mine is a table I put here, but this line and this line make a T. That's deep, okay? Those two lines make a T. That's why it's a T-chart, all right? So I have my x's and my y's. I have 2x equals 3y plus 1. 2x equals 3y plus 1. And I go, this is not really in y equals mx plus b, or not in ax plus by equals c, or plus c equals 0, any of that stuff. So what can I do? You could manipulate this. You could move some things around and get it in one of those forms. Or I could just say, you know what, I'm going to use a T-chart. So you tell me, I want to let x be something, or y, it doesn't matter, but I'm going to let x be something. So what I'm going to do is I'm going to let x be 0 to start with. So I'm going to put 0 in for x. Well, if I do that, then I have 2 times 0 equals 3y plus 1. And 2 times 0 is 0, so 0 equals 3y plus 1. I'm going to subtract 1. Negative 1 equals 3y, and then divide by 3. So negative 1/3 equals y. So negative 1/3. And so when you have this situation, you will from time to time get fractions. 0 on the x, negative 1/3 on the y is down just barely below the axis here, right? In between 0 and 1, but closer to 0. Negative 1/3 is closer to 0 than it is negative 1. So there's my point in red. So what I'm going to do is actually plot these in different colors. So second point, you can let x be something else if you want to. Or I can say, okay, I'm going to let y be something, right? I'm going to let y be 1. There's no magic to that. You could let it be 0. You could let it be 8. When my x-intercept is so close to the axis there, I'm reluctant to let y equal 0 because the 2 points might be so close together, it may not look like a line. So that's why I'm picking 1. Okay? And I look at this and go, hey, this is odd. This is odd times some number equals even. So, maybe it'll help out. Maybe it'll work out for me. Okay? So if I pick an odd number, anyway. So look at that. So then here, 3 times y, 3 times an odd number is going to stay odd. 3 times an even is going to be even. So that's why I picked an odd number plus 1, and then 2 will go into it. Trying to keep away from a fraction there. It's just not necessary for you to think about. There's just a little extra hint there. So here in blue, I'm going to say 2x equals 3 times 1 plus 1. So 2x equals 3 plus 1. 2x equals 4. Divide by 2. And x equals what? 2. So now what this is an ordered pair. Right? That's 2, 1. That's a point on the graph. So 2, 1, 2 on the x, 1 on the y. There's a point. Okay? So now I'm going to find one more point. And so I have x is 0 and x is 2, basically. So I can pick x to be something else. And I wouldn't want to pick 1 here. I want it to be a little further out just because, right? Make sure, again, if 1's a fraction, it maybe I put it in just the wrong place and it doesn't quite look like a line. It looks curved and all this other stuff. So I'm going to pick something a little further out maybe. So you could pick another y. You could even do y, say y is -5 or something and see what happens. Or I could say, so I'm going to say x is 5. I'm going to let x equal 5. Right? Again, that's just going further out. I got 0, I got 2. I'm just going to keep going. I could have picked 4. I picked 5. Okay? So 5. So then if I do this, it's going to be 2 times 5 equals 3y minus plus 1. Okay? So 10 equals 3y plus 1. We're going to subtract 1. Now you can see I actually did this in my head while I'm going to pick this so that it works out as a whole number. Okay? But if you pick 4, it's going to work too. It's just going to be a fraction. So y equals 3. So the point 5, 3 is on here. So I go out here to 5 on the x-axis. I go to 3 on the y-axis, and where do they intersect? Right there. Did I have an extra line there? What did I do? All right. So 5, 3 is this point here. 5, 3 is that point there. So do I have a line? And the answer is yes. If I look at this, these things go right through here, and that's not great. So let me try it again. I'm not sure it's going to be any better, but okay. And then notice what I did. What did I do? I put what on the end of my line? Arrows. Lines go on forever. If you don't, technically in math, when you graph them, if you don't put an arrow, it means it stops. It's a segment. This doesn't stop. It goes on forever. In my class, if you don't put arrows, I will count off. Okay? So you need to find out what your teacher, professor, instructor prefers you to do or requires you to do. Okay? It's one of the issues with graphing calculators that math teachers have sometimes is, hey, why didn't it put arrows on the end of the line? Well, it's graphing something and it just runs out of room to graph it. It's actually going past that. You just can't see it because the screen only shows you whatever. So that's why it doesn't do that. It'd be nice if it did, but it doesn't. Or at least the ones I know about don't. So let's look at another one. 5y equals 2x minus 3. Again, not in standard form, not in slope-intercept form, not in general form. Remember, general and standard form are the same thing, just with that plus c or either equals c. Plus c equals 0 or equals c. So it's not in any of those forms. So we're going to do this. You could manipulate it, but anytime you start manipulating the original problem, right, carelessness could creep in, that kind of thing. So here's a way we can attack it from the original problem without manipulating it, and hopefully lessen our chances for careless mistakes. Again, it doesn't matter. This time I'm going to let y equal 0. Why not? I let x equal 0 last time. Let's let y equal 0. Doesn't matter. Okay? I actually just didn't decide to do that until I was actually about to write on the board. Okay? So we have what? 5 times 0 equals 2x minus 3. 5 times 0 is 0, so we get 0 equals 2x minus 3. We're going to add 3. 3 equals 2x. We're going to divide by 2. So 3 halves equals x. So x is 3 halves. That's between 1 and 2. And y is 0. It doesn't go up or down any of this right there. So 3 halves, 0. That's your x-intercept, right? Crosses the x-axis there. Let me see how we get this extra terminology in here. So now let's find another point on the graph. This time I'm going to let x equal 5 again. Why not? Okay? I'm out here at 1.5. Let's let it equal 5 and see what happens. So if x is 5, I have 5y equals, and there's no magic about putting the first one over here and the second one over here and the third one below. I'm just putting it in space that I have anywhere I have space. It's just wherever I have space. But I am color coding it, so I hope that helps you a little bit. 2 times 5 minus 3, right? So 5y equals 10 minus 3. 5y equals 7. Divide both sides by 5. So y equals 7/5. That's a pretty ugly 7. Let me fix that. So 7/5. 7/5 5/5. So 5, at 5, here's 5, it's up 7/5, which is just barely above 1, right? That's 1 2/5. So 1, it's right up in here, just below 1.5, okay? 1 2/5, like 1.4. All right, so then there's that one. Now let's find one more point, just to make sure we have a line here. So I have something between 1 and 2 and something at 5. Why don't we pick a negative number for x? Or we could pick 0, but pick a negative number for x, maybe -2. I don't know. All right, so then 5y equals 2 times -2 minus 3. 5y equals -4 minus 3. 5y equals -7. And I did not know this was going to happen when I did this. Y equals -7/5. So -7/5. We already know 7/5 is almost 1.5. So then -7/5 is going to be almost down to -1.5, right? A little bit closer to -1 than -2 though. So at -2 we come down and it's somewhere about right here. Does that look like a line? Yep. Sure does. Something like that right there, all right? And notice I put arrows on the end of it because it goes on forever and ever and ever and ever, all right? So I hope this helps out with graph using a T-chart. Just a couple of examples here. But if you were graphing using X and Y intercepts and your origin was both the X and Y intercept, you only have 1 point. Pick an X value and plug it in and see what you get for Y. And then plot that point. That's all this is. You're getting points by choosing an X or a Y value and go finding the other one. That's all you're doing. You're finding an ordered pair. And you're just finding random ordered pairs. There's no magic or whatever. I gave you some hints of how I pick things out and try not to pick them too close together and that kind of stuff. All right? So